Here is my video guide for lesson 6.1.4 titled How Can I Organize My Reasoning? And we're going to organize our reasoning today with flowcharts. Similar to what we did in our similarity unit, we used flowcharts to say two triangles are similar. Now we're going to start organizing flowcharts to say two triangles are congruent. Same kind of outlook. So today, hopefully we can make the connection between those two types of reasoning, those two types of flowcharts. So the first problem here is going to be looking at these triangles at the right, and it says what type of triangle congruence condition do these triangles show. This one I'm going to kind of work through here to give a good example of what this looks like. I can see that I have corresponding sides. Each corresponding side are equal, and so this would be side, side, side congruence. Now I need to make a flowchart organizing that reasoning. And so just like I did with flowcharts for similarity, I see side, side, side. So that's three S's, which means I'm going to need three fact bubbles, excuse me. Three fact bubbles, one for each fact that I need to justify here. So the first one is just going to be that I can say these sides are congruent because I can say 6 divided by 6 equals 1. And so that would be my first fact. 6 divided by 6 equals 1. I can then say, let's do 7 divided by 7.5 divided by 7.5. Sorry, my handwriting is bad on here. With a stylist, you can do a better job than I can. And this equals 1. And then lastly, I have 4.5 divided by 4.5. So I'm showing that they are all congruent to one another by showing that when I divide the sides, they give me 1. Remember, that's the two ways I talk about congruent sides. Either you can say that you can see that they're congruent, they're equal to each other, 6 and 6 are equal, or you can divide them and say that that equals 1. Okay, then I'm going to draw my lines to my conclusion, and my conclusion bubble goes down below. And my conclusion is going to be triangle, let's see here, ABC. Again, sorry for the bad handwriting, is congruent to, and remember to use your congruent sign here, the sign matters. You could lose a point on a test or quiz or formative if you do not include the sign. And then you have congruent to triangle. Let's make sure the order is right. I did ABC, so it's going to be FDE. All right, and then those are congruent by side, side, side congruence, and I put that outside the bubble, okay? The next one is up to you to say, okay, if you copy the flowchart I made here, what differences are in this flowchart than the ones we used to make for similarity? And I want you to list every difference you can find. The one difference I'll give you is going to be this symbol, right? When we did similar flowcharts, that would be a similarity sign, that's a congruent sign. So that's one difference. There are multiples, and I want you to see how many you can come up with. In slide 3 here, it says in Don's congruence flowchart, they used AB divided by FD equals 1, similar to what I did. And in Phil's flowchart, they said that AB equals FD. Do these ovals say the same thing? Can equality statements like Phil's always be used in congruence flowcharts? And so that's up to you to answer. They're just saying dividing equaling 1, is that the same thing as just saying are they equal to one another? Here, we're going to make a flow chart, and these ones get a little more difficult. They're going to test us like the ones on lesson 6.12 in that last slide of that lesson tested us, okay? And so what we have is these triangles down below, and the one thing that I'm going to point out to you that may help you do this problem is, again, our angle relationships. We know that anytime two lines intersect, like this line SQ and PT, they're intersecting, we get this vertical angle relationship, and vertical angles are always equal to each other. So knowing that, can we then set up a flow chart to say that these two triangles are congruent? Okay, and so again, your flow chart, whatever you're going to try to use, will more than likely be 3 fact bubbles, unless it's hypotenuse leg, because that's only 2 fact bubbles, but we'll use 3 fact bubbles, draw a conclusion saying triangle QPR is congruent to triangle STR. Okay, similar to what I did in this slide back here, just probably a different condition, not side, side, side. We don't have 3 sides. All right, in the last slides here, 5, 6, 7, and then 8's a little different, but 5, 6, and 7, you're going to be doing a similar thing. You're going to determine if the diagram to the right is congruent, similar, or not similar at all. Not similar and not congruent. If you claim the triangle is similar, or the triangles are similar, or if you're claiming the triangles are congruent, you need to say these triangles are similar or these triangles are congruent, and then you need to make a flow chart down below. If you think they are neither, then you can just say not similar and you don't need a flow chart. But to give it away, these ones are going to be either similar or congruent. Okay. Again, what I see here is a shared side. Anytime I see a shared side, I know those two sides are congruent. I have an angle, and then what else I see is a set of parallel lines getting cut by a transversal here in blue. Well, when you get parallel lines cut by a transversal, you get alternate interior angles forming here, and alternate interior angles are congruent in this condition. And so we might have enough to say that these two triangles are congruent, and then you can make your flowchart down below. Here, another tough one. Again, look for vertical angles here. Look for your vertical angles here and here, and see if you have enough to say that they are congruent or similar or neither. Again, if you think they're congruent, say so. If you think they're similar, say so. And then if you say congruent or similar, you need to make a flowchart. Here, again, the last one of these kind, you need to, again, justify what you see, if they're similar, if they're congruent, if they're neither. Write your answer in the box, then create a flowchart. Last box here, it says you're involving in a two-triangle problem where the triangle U, V, W, and X, Y, Z, and you know that they are congruent to each other. So what can you coincide about the side lengths and angles of these two triangles? Write down every equation involving side lengths or angles. And so the first one I can think of was that angle U is equal to angle X. And I'm getting that from the statement here because U and X are going to be corresponding. They're in the same position in the statement. So angle U must equal angle X. Another one in that same way would be angle V equals angle Y. Right? Because again, in the same position, I know those two angles are going to equal because all angles, all sides are equal in congruent triangles. One for side length to help you out too would be that side UV is equal to side XY. And that is again because UV is in the same position as XY. So there's more to go here. This is just 3 examples. Get all the angles, all the side lengths in congruent statements there. And then that is it for the lesson. If you have any questions, make sure you reach out and ask.